Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give a simple example related how you can apply gamma distribution to solve a problem. So here we have the life of one computer component in years has a gamma distribution with mean 6 and variance 18. Find the probability that this component has a lifetime of at least 9 years. So clearly that we can see that this one here is the definition of X. So X here represents the life of one computer component and it has a gamma distribution. So actually the whole long sentence here can be simply mathematically represented by saying that X has a gamma distribution with parameters alpha and beta. So that is how some of the examples that you will see later on, especially related to the coming chapters, you can see that this is how the long sentence here can be mathematically represented in a simple manner. We just use this notation to denote that our random variable x has a gamma distribution. And here are the parameters related to gamma distribution. We have alpha and beta. And if you know what's the value of alpha and beta, you can just replace the values inside this, okay? Now, here is the mean, which is equal to 6. In other words, this is the value of expected EX, okay? Expected value of x, which is equal to 6. And then this is variance of x, 18. Find the probability that this component has a lifetime of at least 9 years. So when you talk about at least, that means it can be more than that. So at least 9. So that means the minimum value is 9, but it can be more than that. At least 9. Okay, it can be more than that or equal to 9. Well, if we translate this sentence here into a mathematical statement, it means that you are looking to find the probability x, which is the component has a lifetime, the life of a computer component, is greater than or equal to 9. So that is what we are looking to find. And in order to do that, we need to integrate the probability density function. And the probability density function for a gamma distribution is given by 1 over beta alpha gamma alpha x alpha minus 1 e negative x over beta dx. So this is the probability density function. Where is it? Let me just recap what is gamma distribution. This one here. So if you have a gamma distribution, then this is the probability density function. This is what we need to give as an input when you want to find the probability related to this. Well, so for this question here, this is the probability density function, and you're going to integrate that from 9. 9 is the lower limit, and it goes on until infinity. So that's it. That's the process. However, in order to do that, you need to find what's the value of beta and what's the value of alpha, because we need these values in order to come up with the answer, the final answer later on. And beta and alpha can be found if you consider this information given right here. So we know that expected value of x is equal to 6, and according to the formula, ex is actually the same thing as alpha beta, so that is ex. So that's the first information that we got. Next is variance x. Variance x is equal to 18, and the formula for finding variance x is alpha beta squared. So that's the second information, and we can use these two equations here to find out what is alpha and what is beta. And I'm going to leave it to you guys to get the results. I'm just going to give you what's the answer for that. Well, you can see that later on when you consider solving these two equations, you will get that alpha is going to be equal to 2 and beta is going to be equal to 3. Okay, so you just have to solve these two equations and show that alpha is equal to 2 and beta is equal to 3, and we're going to use this result plug in into this part right here. Okay, now let's do that. Okay, so we are going to consider 9 and infinity. 1 over, well, beta is 3 to the power of 2, gamma 2, and then here we have x, 2 minus 1, e negative x over 3 dx. And that can be simplified to be 1 over 9. And what happens to gamma 2? Well, we have learned the property of gamma function. If you want to find what gamma 2 is, this is the same thing as finding 2 minus 1 factorial, and that's just 1 factorial, which is equal to 1. So, well, we don't need to write that anymore, so it can just be simplified to 1. Okay, never mind, let me just make it even more clear. I'll just write down 1 right next to this number here. Okay, never mind. Now next is x. 2 minus 1 is 1, so that's just x, e negative x over 3 dx. Okay, now 1 over 9 is a constant, and you can just take it out from the whole process. So here we got 1 over 9, infinity 9, x e negative x over 3 dx. And I hope that by now you can already identify the pattern of this function, and you know that in order to solve this integral, you need to apply the integration by parts. Okay, so perhaps we should continue on the next page. Let me just write down what is this part here. So we're just going to have to apply integration by parts, and for that one we need to let u equals to x. So this part here is u, therefore du dx is just equal to 1. Next up, this part here we're going to let it equal to dv. So dv is e negative x over 3 dx, and if you consider doing the integral process for both sides of the equation, therefore we get v becomes e negative x over 3, and at the bottom here we have negative 1 over 3, which can be written as negative 3 e negative x over 3. Okay, got it. Okay, x over 3 right there at the top part. Okay, so we're just going to continue the process here, and I'm going to continue on the next slide because we don't have space. Now what happens is that so here we have probability x greater than 9 is equal to 1 over 9, and we're going to apply we're going to solve the integral part here, this part here, by applying the formula, which is vu and vdu. Okay, integral of vdu. So this is the formula that we're going to apply to solve this integral. So here we have 1 over 9 times with, what is v? V is this guy. So here we have negative 3 e negative x over 3 times with, what is u? U is just x. So this is x. It is going to be evaluated from 9 to infinity. Now minus the integral of v. V is this guy, and du is just dx. Okay, du is just equal to dx. Okay, so negative 3 e negative x over 3 du is dx. This is going to be evaluated from 9 to infinity. Okay, next what we're going to do is this part here becomes 1 over 9, and we're just going to simplify the process in that purple bracket here. Well, this guy here we can write down in terms of negative 3x x over 3 evaluated from 9 to infinity. This one here, negative, negative, positive, 9 infinity. 3 is a constant, you can put it out there. And here we have e negative x over 3 dx, yeah. And then next what we have is, we have, well, let me just focus on writing down the process here for the purple part. Well, for this one here, if you substitute infinity into x and this part as well, you will see that the bottom part will get very large very quickly compared to the top part here. So therefore we're going to have a small number divided with such a large number, and the result is going to be 0. So here we have negative 0 minus, now if you substitute 9 into this, you will get 27. Okay, so this is 27. Let me just, so negative 0 minus, here we've got negative 27 over, now 9 over 3 is E3. So that's what you have, okay, when you evaluated this term here with respect to 9 and infinity. You just substitute all the limits. Plus 3. Now when you integrate this function, it will be, the result here will be, well, e negative x over 3 times with negative 1 over 3, and it shall be evaluated from 9 to infinity. Okay, and I'm just going to focus on the purple part first. I'm leaving the red one here for a while, so just you know, it's okay, so just bear in mind that's what I'm doing right now. So here we are going to have, if you simplify this process here, that becomes negative, negative, it becomes positive, 27 e to the power of 3. Now this guy here is the same thing as, well, you can multiply them. The result here can be simplified to minus 9. So I multiplied 3 with this guy, so you get negative 9. And here we have e negative x over 3 that has to be evaluated with respect to these limits here. Okay, next I have 27 e3 negative 9. So if you evaluate this, you will get, this one here can be written as the same thing as 1 over e x over 3, yeah. So if you plug in the value of infinity into this part, then this bottom value here is going to be very large. So 1 over such a large number is going to be 0 minus, if you substitute 9 into this part here, you will get 1 over e3. Okay, next you can have 27 e to the power of 3. Negative, negative is going to be positive, so positive 9 over e3. So I think that's the thing that you can see, which can also be simplified to 27 plus 9 is 36 over e to the power of 3. So that is the simplest thing that we can come up with when you consider evaluating this purple part here, which is this purple section really. And let me just add on what we're supposed to add. So this is here 1 over 9. Okay, I'm missing this 1 over 9, 1 over 9, 1 over 9, and oops, and here is 1 over 9. And so final answer of this, well, you can see that 36 We can simplify that further. So we have, this is 4, we can cancel, so they get 4. So final result is 4 over E3, which can also be written as 4E negative 3. So that's the probability that the lifetime of the component is going to be at least 9 years. Okay. Well, I guess that's all for now. Thank you very much for watching, and I'll see you in the next video.